Good morning to one and all. I am Dr. Y. Sitaramara, Associate Professor, Department of Mechanical Engineering, Gayatri Vidya Parishad College of Engineering, Autonomous, Visakhapatnam. Today, I would like to give a lecture in the subject of the design of machine elements in the module 1. In that, we will discuss about the introduction to the design of machine elements, which it means the definitions of the machine design. We will discuss and what do you mean by the element and what are the classifications of the machine design and the types of machine design and the basic requirements of the machine design element and what are the considerations that we have to consider in the machine design and general considerations also we should discuss in the machine design and what is the standardization also we will discuss and what is the standards and the codes which we are using in the design of machine elements that we should discuss here in this class here. Coming to the definition, you see the definition of the machine design. Sometimes this machine design also calling as the design of machine elements here. So in this definition of the machine design, which it indicates the use of specific principles, means the Newton's law of motion we are using in the design of machine elements, and the technical information means what kind of material that we are using for designing a component, what kind of manufacturing process that we are using, means it may be sometimes we are doing the turning operation on a lathe or the drilling operation on a lathe or the shaping machine that we are machining or a drilling machine that we are using here. What kind of machine that we need according to the need of the product that you have to be manufactured. What kind of a manufacturing process is also required, maybe the casting or the drilling or the shaping or the planing of a machine or a grinding of a machine. These are all indicating about the technical information and the imagination of the description of a machine here. So how do you imagine the description of a machine? You have to, what kind of dimensions you want to use it here, whether the shaft diameter is how much, shaft length is how much. Like that you have to define and how much tolerance you have to give here for to get the quality of a product to perform its specific function with maximum efficiency and the economy. In this way, we have to define the machine design. And coming to the machine element, what do you mean by the element? It refers to an elementary component of a machine and the several machine elements which are assembled together to form a complete machine which performs the various applications. Means elementary component of any kind of machine we are calling as the machine element here. So there are a lot of machine elements are there here in the design of machine elements. So, and how do you classify the machine elements here? The general purpose elements we have to see and the special purpose elements we have to see here. So in the general purpose elements, the elements which are common to various types of machines serving different applications are called the general purpose elements. Any industry can take these general purpose elements are used in the mass production of the components. So example, you can take the nuts, you can take bolts and keys, axles, shafts, couplings, bearings, gears, belt and drives. These gears which are using in the automobiles and in the couplings that we are using in the railways in order to connect the bogies and the shafts we are using, keys we are using in the couplings here, bolts in the mass production of any kind of machinery that we are using the bolts and the nuts also we are using here and bearings which we are using for the supporting the load purpose we are using here. This is the general purpose elements. And the next one is the special purpose elements. The elements that are used only in the specific type of machinery is for specific purpose. In the camshaft of an IC engine and the crankshaft of an IC engine. For these are used in the power transmission from one shaft to the another. And the IC engine cylinder also we are using. And the blades of a turbine that you are using, of a gas turbine. These are all the specific purpose elements. Means for a particular purpose only these elements are used, unlike the general purpose elements. And the next part is the design. What do you mean by the design? The design is nothing but a plan or the drawing which is produced to show the look and function of a building, machine or other object before it is made. See, in the figure itself, you can see here, there are three types of figures: unprotected type flange coupling, protected type flange coupling, and the marine type flange coupling. In this, when you observe the drawing here, this is the drawing of the unprotected type flange coupling here. In this, you have see the components. Shaft you have to see in the figure itself, and hub we are looking, and the two flanges which connect the shafts here are holding. So this is a drawing of the unprotected type flange coupling. In this, we are indicating the machine elements as the shaft, hub, flange, and the key. These are all the machine elements one could easily identify by looking the diagram itself here. And the dimensions also indicated. This is the plan or the drawing we have to be readily made before you want to design a component or manufacture a component here. So in this, you have to identify the diameter of the bolt, outside diameter of the flange, all the dimensions, because when the dimensions are ready, then it is very easy for the designer to design the component without any kind of complications here. And if you do not have the proper drawing, it is very difficult to design a plan or the drawing of a component. And now coming to the classifications of the machine design. There are three types of design are classified: adaptive design, developer design, and the new design. What do you mean by the adaptive design? It is a design in which we have to make the minor modifications in the existing design or the product. Means examples, the diesel engine you can take, and this the diesel engine again we can modify the small components, small parts, and we have to made it into the large engines. We have to made it here. Similarly, the bicycle you can take the cycle chain of the bicycle is here. You have to make small modification, and that should be converted into a bike. Nowadays, young people are very much enthusiastic to ride on the bikes with higher speed. With that, we have to invent the new bikes here with good mileage, which will attract the youngsters to drive the vehicles here. This is the adapted to the small change we are making here. If you take a table fan with a small resting on the table here, you see here. In the earlier days, the seat will be different. Nowadays, the new component, new materials, sophisticated materials are coming, and does it make the seat design will be different, and the blades will be different, and the comfort which it gives the fresh air to the people here. So that is the adaptive design. And coming to the developed design, here we have to use the existing design is used as a basis to develop the new product in a better way. If you take an example of the electronic components or the equipment, the mobile phones, you can take the mobile phones. So if you take an Apple phone, that is 5S, 6S, 7S, these are all the versions are changing here. For the basic reference that we will take, and we have to do the design we are developing here. And in the electronic components, and the tape recorders also, you can see the lot of changes you have made. Developer design and television sets. Earlier we have the BPL televisions and the Dynara televisions. Nowadays we have the all the televisions, Sony, a lot of companies are there. These companies are the televisions are coming with the internet facility, Wi-Fi facility, YouTube, internet, all are there. Earlier it was not there. This is a developed design, and the modified bikes also there in the developed design here. Whatever we have discussed, bicycle to bike. And the third one is the new design. In this design, a component or product is made from the scratch. That means the designer must have the complete knowledge of the designing. And this is one of the most complicated designs. If you take the example, solar power plant, you can take, and tidal power plant, you can take. These are all used for the generating power. For that purpose, we are using the solar power plants and the 3D printers, which is a new design completely is there for designing any kind of. Earlier, we do not have any kind of the new design, new creativity in the design. That is known as the 3D printers example. This is the new design. Like this, we are classifying the different types of the machine design. Now, what is the basic requirements of the machine elements you see here? So the basic requirements are the strength and the rigidity is one of the basic requirement. The strength means ability to withstand the forces and the moments which are acting on a machine. If you have giving they say 10 newtons force, how much it will be deflection here? It will take maybe 2 to 3 mm or 4 mm. If you still increase the force, still the deflection should be more. And the rigidity means how much stiffness it is having, how much rigid, strong, whatever the forces are acting on the machine. This is the requirement of the basic requirement of the machine element. The strength and the rigidity. The second one is the wear resistance. How much wear the ability of the material can withstand, that is the wear resistance, and the minimum dimensions and the weight. The dimensions of a component should be having the minimum dimensions you have to take, not one or two, length, width, height, and all the dimensions, the stock of the machine component, weight also you have to consider, heights of the components, the distance between the threads if you take, all dimensions we have to take, and the weight of the component also we have to take into the picture while we are designing a component. And then the next one, the manufacturability. What kind of manufacturable process you have to be adopted? That is the casting you have to be adopted, or turning operation, or grinding operation, or the broaching operation, or what kind of operation that you want to do it in order to manufacture a product, and a digital pinning, 3D printing, what kind of operation that you will do, the shaping, drilling. These are all the manufacturing aspects one has to consider before you are manufacturing a component, designing a component. And the safety also. So the safety is also an important factor while an operator is standing in front of a machine or in the steel plant furnaces, whether the operator is able to withstand the temperature generated in the furnace, is able to withstand the furnace. If high pressures or high temperatures are working in the equipment here, that you have to see whether the operator is able to withstand all these or not. And conformation to standards. Whatever the product you are manufacturing, that it should be conform to a particular standard, which are set by the government and the local bodies here. And the reliability. See, what is the service of the life? Whether how much if you buy a component, what is the reliability? How many years that it should work without any kind of failure of a component? That is the reliability you have to consider into the account. Maintainability. You have to maintain all the machinery elements of an equipment of the machine here by doing the proper lubrication when the friction is generated between the two mating surfaces. And these are all you have to maintain the maintainability, and the minimum life cycle cost also. So we have to see here. Then minimum life cycle cost means here that you have to give a component should be minimum life. It will not fail immediately. Whenever the customer purchases it, it will not fail immediately. He will not get a complaint. This component is failed. Like that, he will not come here. And the cycle cost also. You have to have to manufacture a component with little bit the minimum cost you have to manufacture here. That is the important in the basic requirements of the machine element. And what are the general considerations in the machine design? In this, we have to know these are the considerations. Three considerations important are the understanding stress or force. How much force you have to apply on a machine, how much stress we are getting, and what kind of stress, whether it is a longitudinal stress or compressive stress or the shear stress or a combination of the stresses, what kind of stresses that you are getting in a particular machine, or how much force you have to apply to withstand. All you have to consider it here. And know your materials also. Means what kind of material you want to select. You want to have a, you have to reduce the size or optimize the component. The lightweight you need, you have to use the light material to select. Or if it is the, if you have the strong material, the component should be very strong, means the material should be very strong. In such a way, you have to select, depending upon the customer requirement and the application, you have to select it here. And understand the technology, what kind of technology that you want to adopt to manufacture a component here, say rapid prototyping or the digital twinning or the 3D printing. Lot of technologies are coming into the world. Whether we have to utilize the latest technology to prepare a component. These are also using the general considerations in the machine design here. Now coming to the general procedure in the machine design. What is the general procedure? Generally, we are adapted. The need or the aim and the synthesis, analysis of forces, material selection, design of elements, modification, detailed drawing. Means need or aim. Means what is the aim of the customer? What is the need to manufacture a component? And then the synthesis. What is the existing mechanism? How we have to change the mechanism according to the customer needs. And then you have to analyze the forces, where the forces are acting, on which machine, how much force is generated. These are all the forces you have to, forces analysis you have to do it. In which component the more force is acting. So how it reflects on the component here. And how do you select the material? And how do you design the elements here? If it is a key, how to design? If it is a shaft, how to design? If it is a coupling, how to design? If it is a bearing, how to design? If it is a gear, how to design? If it is a belt drive. So you have to design of each and every element. You have to take care in the design procedure of the machine design. And you have to do the modification. What kind of modification you want to do according to the customer's requirement. And then you have to prepare the detailed drawing. You have to prepare it. And finally, you should send it to the production department after you prepare all the drawings. And then standards. What do you mean by standard? It is a set of specifications for the parts, material, or the process. These are all set by the government organizations here. And the ISO, Indian Standard Organization, Bureau of Indian Standards, BIS, American Society of Mechanical Engineers, ASME. These are one kind of the standard. And codes, a set of analysis for the design, manufacture, testing, or the construction of the product. These are all set by the government organizations and the local bodies. If you want to construct a building here, how do you have to mix the concrete and the cement here? There are certain proportions in that whether you have mixed or not. According to some code, you have to do it here. So these are all you must have to follow before you are constructing any kind of building. These are all the codes you have to follow. And what are the simple stresses in the machine elements we have to see here? See what kind of the loads are acting on the machines. Stresses are acting, strains are acting, different types of stresses, tensile stress, compressive stress, shear stress, corresponding strains, and the Young's modulus, and the shear stress and the bearing stress. These are all acting on the machine where it is acting. These are all, does it give the impact on the final delivery of a machine. Now the standardization. What do you mean by the standardization? Is the process of establishing the set of norms to which a specified set of characteristics of a component or a product should conform. Example, standardizing shaft consists of specifying the set of shaft diameters in the materials. What is the objective of standardization? To make the mass production of the components very easier and to make the interchangeability. Means the same components you have to produce here in the larger size. Okay, that is wherever it is possible. The objectives of the standardization. And what are the factors to be considered while designing the machine? First, avoid fatigue failure. The variation in the size of the component should be as gradual as possible. The holes, notches, and other stress rises should be avoided. The proper stress deconcentration, like the pellets, notches, it should be provided to reduce the stress concentration. The part should be protected from corrosive atmosphere. And a smooth finish of outer surface of component, which increases the fatigue lies. The material with high fatigue strength should be selected, and the residual compressive stresses over the part surface increases its fatigue strength. Thank you very much for paying attention to listen this class. Thank you.